Assalamualaikum warahmatullahi wabarakatuh. This is my final year project, which is titled Distributed Web Archiving System Using Rsync and Secure Hash Algorithm for Link Fraud. My name is Muhammad Hafizuddin bin Hamsani, and my supervisor is Dr. Muhammad Azizi bin Muhammad Arifin. Moving on to the background of this study, there is a phenomenon known as the link fraud that can make websites, art, research material, and news reports that is publicly available on the internet inaccessible to users. Centralized web archives like the Internet Archive have tried to capture this history, but the risk of relying on a single repository was demonstrated by the cyber attack that took Internet Archive services offline and caused a data breach in October 2024. Moving on to the problem statement of this project, one of them is content decay. Research shows that 25% to 66% of web links eventually break or go dead, according to Alan and Graham in 2025. This is when images and videos get deleted from social media, we lose the context of important past conversations, according to Rogers et al. 2021. And the second one is server centralization, which relying on a single repository creates a single point of failure that is called SPOF that is highly vulnerable to cyber attacks and infrastructure malfunctions. Thirdly is the platform instability. Big tech companies often like Instagram, X, Twitter often write about massive amounts of user content according to Brown 2022 or use hidden algorithms to silently bury important records of history which permanently destroy our digital records of history according to Gray 2025. Currently, there are three objectives of this study. Firstly is to investigate the current web archiving vulnerabilities and define the system requirements. Secondly is to develop a secure distributed archive architecture using Rsync and secure hash algorithm 256 hashing, and to implement a functional prototype for synchronous and secure data management. And thirdly is to evaluate the prototype's performance, security, and fault tolerance in a simulated network. As for the significance of this study, it proposes a method against the loss of digital knowledge by protecting vulnerable human rights evidence, journalism, and cultural works from algorithmic suppression and platform erasure. It also applies practical networking protocols to build a secure, verifiable archive that records a part of the internet history. Moving on to the methodology of the use case diagram, there are two users in this archive. For instance, there is the user or the anonymous and the administrator. As for the user, they can log in as the user. Moving on to the browsing the archive, they can search by the tag, viewing the post, and view the HTML archive or different formats proposed by the archive. They can download the file to obtain the file. And for the administrator, they can log in as admin. They can ingest content by processing URLs that is publicly available on the internet, and to tag and annotate posts and bulk delete posts, manage permissions, trigger manual rsync push, view the rsync push status, views the integrity report of that post, and remediate integrity failure if anything happens. And then this process shall run the database migration and reset the OP cache and capture network traffic for internal users of the administrator. There is also the cascade ingest auto mode for the auto processing that is related to the ingest content for the publicly available data on the internet that will be using multiple platforms like GaryDL that will be explained in the next slide. The network topology of this project that has one master node and two mirror nodes that is called a mirror node and a mirror 2. This all combined together creates the three different containers within the Docker container that is accessible by users and the administrator as well. It's written in PHP and database is run by SQLite and assisted by a few different programs like single file, GaryDL, YTDLP, and build written in VS Code and some support system like the Chromium file. This is a result of processing a URL from platform like Twitter that auto-downloads the content, that downloads the picture, the username, date obtained, and the platform it originates from. Over here is a result of ingesting a URL that is available from YouTube. It's also able to capture the user, the date, and the platform itself. Over here is a result of ingesting a blogspot URL that's able to save the HTML format of the blogspot itself. In an event of a cyber attack, this system has a proposed protection mechanism that is able to detect file tampering. So therefore, in the event of a secure hash algorithm 256 has changed within the database, it will be detecting the corruption and, and grab a fresh data from the database from the master. And the result over here is for one scenario there is a rsync delta transfer efficiency for the one normal push and the other for repair push for one character file demonstrated in the system. For scenario 2, there is rsync push outcome for one mirror is down. Two nodes are compared for this test, so therefore one is purposely shut down and there's an observation where one operation is successful in one mirror node while the other mirror node is down, and the other one is the latency within the two mirror nodes. One of the future work that I would love to do is to backup data globally and securely in the cloud, and I would suggest to save web pages faster and automatically remove duplicate files, to add tools to bypass more internet censorship, and to capture more pages using industry standard archive formats if there is an opportunity for an upgrade. So in conclusion, this project has been able to prevent link fraud using a distributed web archiving system, and it has decentralized multi-server syncing that eliminates single points of failure, and it maintains uninterrupted access during server outages. It has automated cryptographic self-healing fixes that fixes the corrupted files, and it is able to deliver a permanent fault-tolerant digital preservation framework. That's all from me. Thank you very much.